Hi guys, for the introduction, this is a study on growth exponential model and a Simpson's rule. We will explore how a particular mathematical solution can be used to estimate the population of a specific country. Population estimation plays a vital role in helping us understand how population grow or decline over time. This information is especially important in areas such as ecology, epidemiology, and resource management, where accurate population projections support better decision making and effective resource allocation. Our assignment focuses on demonstrating the usefulness of this solution in providing reliable population forecasts.
To find a particular solution, we're given this equation for population growth, dp over dt equal to kp. Step 1, we separate and integrate and simplify the equation, which will give us the general equation p equal to a e power of kt. Step 2, we use the first data point at t equal to 0 and p equal to 11,622,665 and plunging it into the equation, which will give us a equal to 11,622,665. Now our equation is p equal to 11,622,665 times e power of kt. Step 3, use the cycle data point at t equal to 1 and p equal to 12,000,031,430. So by inserting the data into the previous equation and divide both sides and take the natural log, we get k equal to ln 12,031,430 over 11,622,665 equals to 0.0346, which will give us the particular solution where p equal to 11,622,665 times e power of 0.0346. From the data set given, the graph for particular solution was constructed where y equal to population and x equal to year. And from the graph, we can see that it is increasing exponentially. Using the given data set before, we can find the percentage error by using the actual minus epsilon over actual times 100% equation, which will give a 4.58% of percentage error. Let's say okay.
Now, let's look at the future and past value of Niger's population using a mathematical model. So in step 4, we predict the future population. There we use the formula and we put T as 21 because 2000 is taken as the base year, and we substitute the value. The calculation gives us a predicted value is quite close to the real data. Next, for the step 5, for the past population, we predict the population for the year of 1999. We set t as -1 and put it in the same formula, and we also get the data which is quite close to the real one. So through both future and past predictions, this shows how mathematical models can help us estimate population trends quite accurately.
Now, I'm going to talk about the reasons behind Niger's population growth in the past. First, Niger have one of the highest fertility rates in the world, with women having an average of 6 to 7 children. This is influenced by cultural and religion beliefs as well as economic factors that encourage large families. Second, there have been a massive improvement in healthcare over the years. Child mortality has significantly decreased, so more children can survive into their adulthood. This has contributed a lot to the country's growing population. And third, there's a limited access to family planning in Niger. Many people don't have access to contraception or proper reproductive health education, which result in an unplanned and frequent pregnancies. Together, these three factors explain why Niger's population have grown rapidly in the past. Next, these are the reasons why Niger's population are expected to continue its rapid growth to the future. First, Niger has a very youthful population structure. A large portion of the population is under the age of 15. As these young people grow up and start families of their own, the birth rate will remain high and the population will keep increasing. Second, there's a decline in infant and child mortality. Thanks to the gradual improvement in healthcare and access to basic services, more children are surviving past infancy. This means that more babies born today are likely to grow into adulthood, which adds up to future population growth. Together, these two factors is expected to drive Niger's rapid population in the future.
To conclude, our assignment shows that particular solution is useful for estimation of population in certain country. The significance of estimation of population is that it allows us to track how population will grow or decay. Therefore, in fields like ecology, epidemiology or resource management, knowing the exact projected population helps with decision making and resource allocation.
Evaluate the following equations using Simpson's rule with seed and 10 intervals. Give your final answers correct to 7 decimal places. Type equation in F15 bots in Excel to determine H. G15 plus F15 over H15 will give the value of H. Next, type the equation A16 plus F15 to determine the value of X in A16. Continue to repeat the same steps but with different boxes respectively to get the net value of X. Next, type this equation on B15 to determine the value of fx for x equals 2. Continue to repeat the same steps but with different cells to get the net value of fx. And then type equation equals B15 times C15 on D15 cell to determine the value of coefficient times fx. Continue to repeat the same steps but with different boxes to get the net value of coefficient times fx. Type in the equation I15 over 3 times D22 to get the area of approximation for n seats with 7 decimal places. And in the bottom you can see the entire formula for Simpson's rule. This is the graph for the previous question where we can see there are 6 different boxes with the same width representing the 6 subintervals.
Right, so in this part of the slide, we're going to look at the ways on how we can do the Simpson rule for 10 subintervals. So first of all, you're going to have to type the equation in as per step 1 on the bottom left corner. A29 plus F28, referring to the boxes inside the Excel sheet, and then you're going to need to continue to repeat the same steps but with different boxes respectively to get the next values of x, so on and so forth until you get to the 39th row. And moving on, you're going to type the equation on B29 to determine the value of fx for x equals to 2, and then you're going to continue to repeat the same steps but with different cells to get the next value of fx. And the third step is to type equation equals b29 times c29 on the d29th box to determine the value of coefficient fx, and then rinse and repeat until you get all the values. And for the variables, you're going to have to type equation on a tab on any side of the Excel equation. In my case, I use Z29 minus F29 because it's the 29th row over H29, and then it will give the value of H. And this H is the constant of the whole equation. And for the last part of the 10 subinterval, you're going to have to type in the equation equals I29 over 3 times the total of all the calculation to get the area of approximation for n equals to 10 because we're doing 10 subintervals. And as you can see below, that is the equation that you get when you put all of the values in the table into an equation, which will ultimately give you the end value. So this is the graph of normal distribution when we use 10 subintervals for the Simpsons rule.